Good morning, good afternoon, whenever you're watching this. If you're watching this, you should already had your warm-up done. Let's go over the warm-up. Number one says, how do the properties of a compound compare to the properties of the elements in them? Think about it. Properties of a compound. This was a question the other day on the quiz. They're the same. If they go, properties of a compound compare to the properties of the elements that are in them. If they're the same, they're the same. If you put the properties of the elements into there, they're going to be the same that make up the compound. So it's the same. They're not going to change or anything like that. Number two, how do the properties of a mixture compare to the properties of the substances in them? Well, guess what? The properties in the mixture that go in to make it, they're going to have the same properties. It's going to be also the same. Not going to change. You're not going to put something into a mixture and all of a sudden change the mixture. It's going to be the same. Number three, what is the name of this element? If you look right over there, the name is chlorine. Chlorine. What is the atomic symbol for the element? Cl. You guys practiced this yesterday. You should be all right with this. What is the atomic number of this element? It's 17. Atomic number is 17. What is the atomic mass of the element? Well, it's 35.453. So go ahead and scroll down. I'll have your warm up, your PowerPoint up, and here we go. Go ahead and copy it down. Now, if you need to pause this video as I go through, feel free to pause the video as I go, as you see fit, and then you'll be able to go at your own pace. But the LEQ, why are all the elements on the left side of the periodic table shiny, malleable, and conductive? Well, you're going to find that out throughout today's lesson. Also, word of the day, atomic mass equals protons plus neutrons in the nucleus of an atom. All right, now you can find that on the periodic table also. Now, go ahead and press pause if you need some more time to click that. I'm going to go ahead and move on. You go at your own pace, okay? Mendeleev, we know Dmitri. He organized the elements, all right? Dmitri Mendeleev, he organized the elements by increasing atomic number. As the number goes up, from left to right. From left to right, all right? But he also organized it from top to bottom, all right? From left to right and top to bottom. That will be a quiz question coming up, so be prepared for that. He organized the elements in columns by the way they reacted. Now, columns are up and down. Basically, each one of these are a family, or they're also called groups, okay? Now, he tested them, and the way they reacted, he grouped them together. This is what he figured out. So groups or families, up and down. Periods are from left to right. Groups, up and down. Periods, from left to right. A period is a row, left to right on the periodic table. You can see like the red, that's a period. The orange is a period. The yellow, the green, the light blue, the dark blue, the purple. Now these guys, remember, if you look on the back on ours, there is a star there and a 2-star there, and it goes right up here. There's a star there and a 2-star there. So normally they would be there. Now, you should recall from the video yesterday that they should be in a cylinder or a circle, but it would expand it too far off the board so you wouldn't even be able to see it, all right? So these guys are placed in there, and they're in these rows. Or periods. A group or family. A group or family is a column up and down on the periodic table, and they have similar properties. Now, these guys are a family. They have similar properties. So are these. These have similar properties. And I'm going to show you what some of these are, okay? But that's how the periodic table it's been grouped. That's what Dmitri figured out. Now, families on the periodic table. Elements on the periodic table can be grouped into families based on their properties. Each family has a specific name to differentiate it from other families in the periodic table. So they all have groups of names. Now, will you be tested on the groups of names? Probably not. Maybe on the noble gases, and I will show you where the noble gases are located. All right? Now, here's the family names. I don't know if you can read this on the video. Right here is the alkali metal family. Now, these guys are super reactive. They will react with air. That's why you will not find them in nature. Basically, if scientists wants to use these guys, what they have to do is get them out of another substance. And they're usually stored in some kind of oil base, so they don't react with any gas in the air. Then you got the alkali earth metals right here, the earth metal family. You got transition metal families right here. Then you got the boron family. Guess what is right there? Boron. Right, you got the carbon family, and guess what's on top? Carbon. The nitrogen family, yes, you guessed it, right there is nitrogen. Oxygen family, oxygen. Halogen family, right there. Then you have the noble gases. This is the one right here in the greenish color right there is the one that you might be tested on. So always know some of the noble gases, all right? Noble gases, helium, neon, argon, krypton, stuff like that. Now, all metals. Now, this is key because you're going to have to know this. Predominantly, most of the periodic table is metals. We found that out yesterday. All metals. Look at the red. All metals. All metals. All metals. All right? All metals. Then, all metals are conductive. That means electricity can pass through them. Ductile and malleable means they can be rolled down in like little wires, little thin wires, and malleable, it means that they can be bent and shaped. That's why we use a lot of metals. If you think about wiring a house or something like that, they do that with copper wiring and stuff like that because of these three things. You can squeeze it down into a small little wire. You can bend that wire easily, and it can conduct electricity. You want wiring in your house so you have electricity, and that's why they use metals. On this, you also see that we do have some non-metals over here, and we got some metalloids, which we'll talk about in a little bit. All right, noble gases, like I said, right over here. The inert gases, they don't react with anything, all right? Noble gases are a special group of nonmetals. They exist as gases, and they're not reactive with other elements. Now, neon is cool because if you think about neon lights, when they say neon lights, they put gas, this neon gas, in a tube, and they charge it with electricity. And guess what the neon light does? Well, it lights up. It glows. That's how they do a lot of the signs for businesses and stuff like that. So, noble gases. You have to remember noble gases on the far right-hand side, okay? Helium's up here. So, it always starts with helium up there with the noble gases. Metalloids. You're going to see the stair step, all right? We start right up here and move down. Metalloids are located on the stair step of the periodic table. They have properties of both metals and non-metals. Now, I'm going to go back real quick to show you where we're talking about. It's the one in the yellow. See the yellow? Those are the metalloids. Te, Sb, Sas, Si, boron, all metalloids. Let me catch up. All right, here's your periodic table outlay. I need everybody to come up to the front of the room and grab a periodic table because you're actually, hopefully you can see that. You're going to color the periodic table right now. All right, come up, grab. You're going to have to grab from the front table a whatever color you want. I would grab red, blue, and yellow or green, it doesn't matter. As long as you do a key on your map, that's what counts. Now, your periodic table. We're going to do metals first. So as long as you put a key, I'd put a key right up there. So what I would do, if I was going to use red, I would put a red little box or something like that right there. And right beside it, I would say metals. So I would put a red little thing right here. And then right beside it, I'd put metals. Now, you're going to be able to use this periodic table on the test. So you should do a good job with this. Because if you don't do a good job with this, guess what? Don't ask me for another periodic table that's marked like this. I'll give you a periodic table, but it's your job to mark it up. So, metals are in red or whatever color you choose, but it has to be the same colors. Make sure you get them all, okay? These over here, PO right there, BI, all these. And these down here, these are also metals. I'm going to pause that. If you need to pause it right now. I'm going to go on. But you can pause so you can see which one's the color that color. I'd say red, but you color it whatever color you want. Just make sure it's the same color. Now, this is your non-metals. All right? Your non-metals. I would do the same thing. If I'm going to color it blue, I'm going to put a little blue box up here, and right beside it, I'm going to label it non-metals. Then you have a key, so come Friday or next week when you're taking a test, you would know this. All right? Don't forget hydrogen up here. It's a non-metal too. That's why if they said do a cylinder, hydrogen would be with these guys. So go ahead and pause if you need to pause and look. All right, moving on. Here is your periodic table. And here is your metalloids. Metalloids, you got right through here. It's your stair step, okay? Now, what you're going to notice after you get everything collared, that GE, I believe, let's see, it's GE, and SN are not in any group. Now, if we go back here, GE is a metalloid, SB is a metalloid, SN is a metal. Whoever did the PowerPoint might have messed up. So GE will be a metalloid, SN will be a metal. So you haven't colored them anything because they haven't been labeled. So let me stay on this for a second. So if you need to see the stair steps, feel free. Now, so go ahead and pause. We are done with the PowerPoint, but after you get done coloring, you have some independent work to actually get done. So there's your notes. There's independent practice scavenger hunt. You can use your periodic table that you just colored. Go ahead and finish that. Now, hopefully you get done. If you weren't messing around, you should have some time to get this done. And if you do get done, remember what we were doing yesterday. Some people got done and some people did not. We'll have to finish that. If you have any questions, go ahead, ask me. I'm here. But that should be enough time for you to actually get your notes done, work quietly. You're not working with a partner on this. You are working on yourself. All right. Work hard.